This is one line of shell. It launched an agent that wrote code, reviewed it, and shipped it. It ran unattended in 30-minute stretches, nobody in the room. Read it left to right. Every flag on this line answers one fact. No human is watching. All but one, and that one is about the bill, and one flag on it has the word dangerously in its name. You will set that flag on purpose. The whole setup exists to earn it. You have handed a coding agent something real to do, walked back an hour later, and found it stopped, not crashed. Stopped waiting on you. It stopped to ask whether it could edit a file. It stopped to confirm a command. It stopped to trust the very folder it was working in. Interactively, you tap yes and move on. You are the answer to every one of those prompts. Run it headless and there is no you. Nobody taps yes. You saw run one die at a trust dialog 12 minutes in, and you saw a background task get killed at 600 seconds. Neither was the model. Both were defaults that assume a human is at the keyboard, and there are a dozen of them. Headless is not a smarter model. It removes every place the software stops to ask, then bounds what is left. Here is the receipt. This line is not my idea of a good setup. It is the literal function the pipeline shells out, copied from its script line for line. Every phase of every run launched through it. The run does not read the screen the way you would. It reads the result the tool prints back. Start at the agent itself and the two flags that assume you are gone. The first is print mode, -P. Interactively, the tool opens a session and waits for you to type. Print mode runs the prompt once and returns. No session, no cursor blinking at a human who left. The second flag is the output format. You set it to JSON. This is the flag people skip. It turns the run into a program, not a demo. A human reads the screen, sees the summary, and nods. A script cannot read a screen. So the tool prints a structured result, and the loop parses it. It pulls out the total cost to track spend against a ceiling. It pulls out an error flag to tell a real failure from a clean pass. Without that flag, the agent still works. But nothing downstream can tell whether it worked, and an unattended run is defined entirely by what happens downstream. Print mode removes the human from the input. JSON removes the human from the output. Next, the two clocks. An agent that is stuck does not know it is stuck. It will retry the same failing step calmly, forever, and bill you for every attempt. So you bound it in 2 dimensions at once. The first bound is wall clock time. The launch line is wrapped in a timeout set to 30 minutes. That is the leash from the hook. Each session gets 30 minutes untouched. If it hangs, the timeout sends a stop. 30 seconds later, if the process is still alive, it sends a hard kill. The timeout returns exit code 124. The run reads that as a timeout, saves its state, and exits. Nothing is lost because the whole thing is built to resume. The second bound is not about time. It is about actions. Max turns set to 50. A session gets 50 agentic turns, then it ends no matter what. A model spinning in a tight loop burns turns, not your night. Time alone is not enough. Actions alone are not enough. A run can sit quietly under the turn cap and still waste 30 minutes. It can also burn all 50 turns almost instantly. You need both clocks, because either one can run away while the other looks fine. All to earn one switch. Now the flag from the hook, the one with dangerously in its name, interactively the tool asks before it touches anything, every file edit, every command, a prompt waiting for your yes. That is the safety rail for a human. For an unattended run, it is a wall. Every single tool call would raise a prompt no one can answer. So for the phases that write code, you set the flag that skips them all, skip permissions. It is named to make you flinch, and you set it anyway on purpose. And here is the first layer that earns it. That same switch refuses to run as root. Try it under root or sudo, and the pipeline stops before it starts. It prints 2 lines and quits. It refuses because bypassing permissions does not work as root. It would rather fail loud and early than fail confusing deep in a run. The one switch you need for autonomy is the one you must never hand the root account, so you run the whole thing as a regular, unprivileged user. That guard is necessary, but nowhere near enough. With this flag, even a non-root agent can wipe the project or leak what it reads. So the guard is only the floor, the clocks, the ceiling, and a disposable workspace bound the rest. Powerful switch, powerless account. Watch the line do its work. The same command fires phase after phase, spec, then architecture, then the build. Nobody touches the keyboard, nobody approves anything. The timestamps move at a pace no human types at, and the chair in front of it is empty. The only human decision already happened once when these flags were set. Now cost, and this is the flag people get backwards. Unattended does not mean point the biggest model at everything and walk away. That is how you wake up to a bill. The model flag is set per phase, not once. The pipeline runs two. The heavy model, Opus, runs the phases where a wrong call is expensive. The specification, the architecture, the adversarial reviews, the judgment work, where a bad decision poisons everything downstream. The cheaper model, Sonnet, runs the phases that are mostly execution, the build loop, the deploy, the end-to-end pass, a mechanical check that the required pieces exist, and the test pass. This is a deliberate split, and it is the real cost control, more than any ceiling. A ceiling only stops a runaway. The model split decides what a normal run costs in the first place. You are not paying for the smartest possible answer at every step. You pay for it only where being wrong is expensive and pay less everywhere else. One flag, read from a per phase variable. It is the difference between a setup you can run nightly and one you run once and never again. The flags launch the run. The envelope is what makes it safe to leave. This is the part you write once, in a config file, and then stop thinking about. Read it like a budget. Every line is a hard stop you priced before you left. A wrong turn stays bounded, not catastrophic. Start with money. A cost ceiling, $25, rechecked before every paid session. Not once at the top, before each one. Then the round trips. If a phase fails review, the loop fixes and retries. But only 3 passes, then it halts for a human. Each build phase gets 6 iterations, no more. And the human gates. At certain phases, the run is meant to wait for a person to approve. Interactively, it prompts and waits. But there is no terminal to prompt and no person waiting. So it does not guess and it does not blow through. It exits with code 10 and stops. It tells you to rerun when you are ready. There is a lock file, so a stray second process cannot start a competing run. And there is a pre-flight check. It refuses to start if the brief is empty. An empty brief just burns an expensive planning session on nothing. None of these are clever. Everyone is a decision you make once at rest, not half awake with the run already moving. So, back to the line, and the word that should scare you, dangerously. Why is it safe to walk away from a command with that word on it? Skip permissions lets the agent run any command you could. The setup does not trust it, it contains it, and the one phase that could touch production never gets this flag. Deploy runs at default permissions, dry run only. 2 clocks hold each session to 30 minutes and 50 moves, a $25 ceiling, and a code 10 stop bound the whole run. None of it is intelligence, it is configuration set once. So one action. Before you run anything unattended, write the envelope first, the ceiling, the timeout, the user it runs as, next, one level up, the loop that runs this line through the whole chain in a fixed order, no human in the sequence. Subscribe if you want that loop taken apart the way this line was, every claim backed by its own log line.